Hi, that we continue the testing contingency tables now that we have our code. So remember that we are testing the hair eye color table. Actually, this table have two pages. One is for male and one is for female. So this is just the first page of the data set. And we want to test this with chi-square test. So we have calculated the distance between observed number and the expected number. Then divide by expected number, then take the summation. So this is the chi-square statistic, and this follows the chi-square with degrees of freedom r-1 times c-1. In our case, this is 3×4 table. So this is the 3-1 times 4-1, so df is 6. So chi-square statistic was obtained here. So R calculates the all chi-square statistics within the function automatically, and the degrees of freedom is here. Then p-value. P-value is you can use the chi-square p-chi-sq function to calculate, but the R automatically do that. And the p-value is 0.04. So if the significance level is 0.05, we reject null hypothesis. Maybe it's on the boundary, but still we reject. So we can say that the hair color and eye color are somewhat related. So here is warning message. So warning message isn't an error in R. So sometimes we can ignore it, and it says chi-square approximation may be incorrect. So that means this is approximation. So this is basically by the central limit theorem. So Eij minus Oij, if sample size is large, so this converges the normal distribution. So normal square is chi-square. But the Eij is not very large. So some Eij is probably less than 5. Then we get this message. So it's not very accurate. So yeah, but we have some limitation, but still that we can say the chi-square test reject H0. Okay, so the independence is rejected, and we go back to the table again to see what's happening. You can see that, okay, so more students have the brown eyes, less students have hazel or green, and more students have the black hair or brown hair, not many the red hairs. So it sounds not much pattern here, but if you see some specific feature, for example, the focus on the brown eyes and the green eyes, and hair color black and red, so it seems that the students with green eyes are more likely to have the red hair, and the ratios are pretty different, 7:3 and 10:32. So we can say that these two are somewhat related, maybe also the blue. But the blue and the green are different in the sense that we have more the brown hair students. So it sounds that the eye color and the hair color are somewhat related. So it's consistent with the test result that the H0 independence is rejected. Yeah. So this is the chi-square test. And another example. So at the table that shows that the blood type of 100 Asian Indians and the 100 Americans. So these are actually the fake data, but the numbers are typical numbers for these countries. So this comes from some statistics. And test if the distribution of blood type and the countries are independent or not. Or we can say that the India and the US have different pattern in blood pressure, blood type. So we can say that way also. So sometimes some people say this is the test for goodness of fit, and they distinguish this from the test for independence. So that's why we have two sections here, but basically the same. So if Indian and US have the blood type patterns, that means blood type and the countries or country of origin are independent. So basically it's essentially the same mathematically. And you can see that it's probably not independent because more blood type A in the United States and more blood type B in India. Others maybe not much difference, don't have much difference. Okay, so now that we do the goodness of fit test. So we define the matrix. This is the numbers for Indians, and this is number for Americans. And these 4 columns is the A, O, A, B, A, B. And the same for the second one. And you can put just this matrix to do chi-square test. And chi-square value 18.3, degrees of freedom 3. So this is 4x2 table, 4x2 table. So maybe 2x4, 2x4 table. So degrees of freedom is 1/3, so 3. So p-value is very small. So df3 expected the chi-square is 3. So 18 is 6 times larger. So p-value is very significant. So we reject the null hypothesis that country and blood type are independent. Yeah, so it looks type A and type B have clear difference for these 2 countries. So it's reasonable. So blood type is interesting data, and not all countries have that statistics, but depending on country, the proportions are pretty different. Yeah, and if the chi-square table is the 2x2, then this test is equivalent to the test for 2 proportions. So, for example, we have tested the admission statistics, the matriculation rates for the Wayne State University the medical school, and if students come from the U of M, 840, so 85 out of 483 students are enrolled in the medical school, and for Wayne State, 54 out of 143. So if we make a contingency table, okay, so the enrolled and the not enrolled and the U of M and the Wayne State University, then we can make a table to 85 and the 483 minus 85 and the 54 and the 54 minus 143, sorry, 143 minus 54, then we can make a 2x2 contingency table. So we can do chi-square test. Actually, there are the proportional test for the 2 samples. So this is actually done as a chi-square test. So actually, the test for 2 proportions are not necessary. Just always you can use the chi-square test.